This video is part of a series of video instructions on the BioGrace greenhouse gas calculation tool. This is instruction 2.8, calculation of field N2O emissions. Please note that field N2O emissions only have to be calculated if you make greenhouse gas calculations for a cultivated crop, including energy crops like grasses and woody biomass, such as short rotation copies. The instruction will show the BioGrace 2 Excel tool, but can also be used for BioGrace 1. As in the BioGrace 1 Excel tool, the calculations are made in exactly the same way. One exception to this is that in case of BioGrace 1, the GNOC model, which I will explain in a moment, is not yet applicable. This is expected to change after the update of RAD Annex 5. Until then, in case of BioGrace 1, the IPCC N2O calculation sheet in version 4.c of the tool should be used for the calculation of field N2O emissions. For pathways with crop cultivation, field N2O emissions are to be taken into account in the greenhouse gas calculation of your product. These emissions mainly occur during the crop production step because of soil's microorganisms activity. In each pathway during the crop cultivation step, field N2O emissions are to be calculated. In the BioGrace tool, two models are used to evaluate N2O field emissions: the Global Nitrous Oxide Calculator, GNOC, and the IPCC 301 methodology. In the BioGrace 2 tool, two specific sheets are provided, one sheet for each method of calculation. The GNOC is an online calculator developed by JRC that should be used to estimate N2O field emissions for all the types of crops available in a GNOC model. A list of crops is part of the online GNOC calculator, as will be demonstrated in a moment. For types of biomass that are not included in the GNOC tool, a calculation following the IPCC 301 methodology should be made. In the relevant pathway sheets, a link to the sheet N2O emissions GNOC has been placed right below the cell where the information about N2O field emissions should be provided, as shown here. After opening the sheet, you will find a step-by-step introduction in the box at the top of the sheet. To determine if you should use the GNOC sheet for your N2O emissions, you first go to the website of the GNOC model and check whether your crop is included in the list by using the drop-down box here. If your crop is included, you can calculate the field emissions. If your crop is not included, use the N2O emission IPCC sheet of the BioGrace 2 tool, which I will explain later in this video instruction. The N2O emission GNOC sheet in the BioGrace Excel tool is not meant to make any calculations, but to gather all information that has been used to make the calculations. These calculations must be done directly on the GNOC website by filling in all the data. I will give an example. Imagine that you are a farmer in Gelderland, which is a province in the middle of the Netherlands. You want to make a calculation on N2O emissions for rapeseed cultivation at a field in the village called Bennekom. You will have to start with collecting all the data that you need from measurements at your field or from agricultural statistics within the province. At the top of the website, you can indicate the location of cultivation. This can even be specified at field level by using the map at the right, like this. Then select the name of the crop from the drop-down list, the soil type, whether or not the crop is irrigated, and the amounts of fresh yield, mineral fertilizer and manure. Once you have provided all relevant information, the website provides the total N2O emissions here. Please note that the result of the GNOC website is in kilogram nitrogen as part of N2O per hectare per year. Whereas in the BioGrace tool, you should give the value in kilogram N2O per hectare per year. To get a result in the proper unit, you fill in the value from the GNOC website in the sheet N2O emissions GNOC. Then the value in the correct unit is calculated, here. This value can be transferred to the cultivation module of the BioGrace pathway sheet in which you are working. To assist the verification of your calculation, enter also the data that are asked for on the GNOC website to make the calculations, in this box here. For more detail on the GNOC and its calculations, please refer to the GNOC website and its online tool manual. In the last part of this instruction video, I will give an explanation on how to use the N2O emissions IPCC sheet. This sheet has to be used for crops that are not covered by the GNOC. It follows the IPCC guidelines 2006 for N2O emission calculations. Please see the BioGrace calculation rules document for specific recommendations about the use of this method. At the beginning of the sheet, a short introduction presents the methodology used with the additional hypotheses used in JRC calculations that have been incorporated in the module. This module details the calculation on the 3 N2O emission sources that occur: direct N2O emissions from the field, indirect N2O emissions due to leaching and runoff, and indirect N2O emissions due to NH3 and NOx volatilization. For field N2O emission calculations for a pathway, please apply the following steps. First, choose the name of the crop and the general information about your pathway in the crop data box. You can choose between 3 different crops: eucalyptus, poplar, and corn or maize wool crop, using the drop-down list here. To calculate N2O emissions for a crop that is not listed, enter the name of the crop in Table 1 and fill in Table 4 of this module. More information on how to fill in Table 4 is available in IPCC 2006 Chapter 11. In case of land use changes or modified management practices, the LUC or ESCA sheets of the BioGrace 2 Excel tool should be used to calculate the carbon loss. Enter the result of the calculation in cell D30 here. The use of these 2 sheets is explained in a separate video instruction. When the ESCA sheet is used to calculate carbon losses due to change in agricultural management, please note that only when negative results are obtained, carbon losses are actually occurring. In this case, you should change the sign of the result and insert the obtained positive value in cell D30. In case of calculation of direct N2O emissions from managed soils, 2 more input data are needed for direct N2O emission calculations: the quantities of synthetic nitrogen fertilizer and the quantities of organic nitrogen fertilizer applied. In tables 2, 3, 4 and 5, intermediate calculations are shown and the total of direct N2O emissions are given at the bottom of the box here. Please note that in case of calculation of indirect N2O emissions from managed soils, automatic calculations are made using previous input data. Intermediate calculations for N2O indirect emissions due to NH3 and NOx volatilization and leaching are shown in Table 6 and 7 here. Finally, the total N2O emissions are given in yellow at the bottom of the sheet here.